Continue on Chapter 5, Functions and Graph, 5.4, Exponential and Logarithmic Functions. These are the learning outcome for this lesson. Relationship between an exponential and logarithmic function. Logarithmic function is the inverse of exponential function, and so is exponential function is the inverse of logarithmic function. Since log x base a is the inverse of a power of x, therefore domain of log x base a is the range of a power of x. So domain of f equal to range of f inverse, and range of f equal to domain of f inverse. These are the graph of log and exponential function on the same axis. So log x base a is here, then graph of y equal to a power of x is here. So we can see that these two are symmetrical at line y equal to x here. Therefore, log x base a is the inverse of a power of x. Example, given fx equal to ln 3x plus 2, find f inverse. And then sketch the graph of f and f inverse on the same axis, take domain and range. So first we need to find f inverse. To find f inverse, we need to use the same properties. F of f inverse equal to x. F is ln 3x is f inverse plus 2 equal to x. Then simplify 3 f inverse of x plus 2 equal to ln, move to the other side, is exponential of e, and then f inverse equal to e power of x minus 2 over 3. So this is the inverse function. And sketch the graph of f and f inverse. So fx equal to ln 3x plus 2. Graph of ln positive, x positive from below to the right. And then second asymptote, 3x plus 2 equal to 0, x equal negative 2 over 3. Asymptote is negative 2 over 3 here. And then graph is positive. So we need to check whether y-intercept is positive or negative, either here or here. So y-intercept is when x equal to 0, y equal to ln 3 times 0 plus 2. So ln 2 is positive. Therefore, sketch the graph. Graph is close to asymptote and then to the right. This is fx. Y-intercept is at ln 2. And we have x-intercept here. So x-intercept is when y equal to 0. Ln 3x plus 2 equal to 0. 3x plus 2 equal to e power of 0. X equal 1 minus 2 negative 1 over 3. F inverse is the reflection of fx at y equal to x. Here is line y equal to x. F inverse will have asymptote at negative 2 over 3. Here is the asymptote. And cross at negative 1 over 3 and ln 2. So close to asymptote and then moving up. This is the F inverse. Here is negative 1 over 3 and here is ln 2. The inverse function will cross exactly at the same point f, fx. Lastly, domain and range for both f and f inverse. So domain of f equal to range of f inverse. Domain of f is here. So fx is here. Domain cannot cross the asymptote, means from negative 2 over 3 to positive x infinity. Range of f equal to domain of f inverse. Range of f is from negative infinity and did not stop at any point, so to infinity. From negative infinity to infinity. Next example, given fx equal to log 2x plus 1 base 3, find f inverse. Then sketch the graph of f and f inverse on the same axis, take the domain and range. Again, find f inverse using f of f inverse equal to x. F is log 3, 2x is now f inverse, plus 1 equal to x. So 2 f inverse of x plus 1, and then base will become base of index 3 power of x. Then simplify, f inverse equal to 3 power of x minus 1 over 2. To sketch f and f inverse, for f we need shape positive x, positive log, so from below to the right, and then asymptote is 2x plus 1 equal to 0, x equal negative 1 over 2. And then x equal negative 1 over 2 is the asymptote, so here. And then from below to the right, the graph will cross y-axis, means y-intercept is when x equal to 0, y equal log 3, 2 times 0 plus 1, so log 1 base 3 equal to 0. Then intersection point is here, 0, 0. Means the graph from asymptote, this is graph of fx. And then intersection point is 0, 0. And then we have f inverse. F inverse is the reflection of fx at y equal to x. So f inverse will have asymptote at y equal to negative 1 over 2. Then sketch graph from asymptote, cross at 0, 0 and towards positive y. Label the graph, this is f inverse. Domain for f equal to range of f inverse equal to, domain of f is here from asymptote negative 1 over 2 to infinity. And then range of f equal to domain of f inverse equal to, from below negative infinity to infinity. This is the graph for f and f inverse on the same axis. Given fx equal to e power of 2x minus 1, find f inverse. Sketch the graph of f and f inverse on the same axis and state the domain and range for both. So we need to find f inverse. F of f inverse equal to x. F is e, 2x is f inverse, minus 1 equal to x. Then e to f inverse x equal to x plus 1, and then e move to the right hand side, 2f inverse x equal to ln x plus 1. And then f inverse equal to ln x plus 1 over 2 equal to 1 over 2 ln x plus 1. Sketch graph. You can choose whether to sketch the graph fx or f inverse first. Since ln is easier, we sketch the graph for f inverse first, then fx. First, we have ln positive, x positive, so from above to the right. Second, asymptote x plus 1 equal to 0, x equal negative 1. So asymptote is at x equal negative 1 here. Then from below to above, find the y-intercepts as the graph will cross y-intercept at one point. Y-intercept is when x equal to 0, y equal to 1 over 2 ln 0 plus 1, ln 1 is 0. So intersection point is here. 0, 0. Then sketch the graph from asymptote to positive y. This is F inverse. Fx is reflection of F inverse at y equal to x. F inverse has asymptote at x equal to -1. So Fx will also have asymptote at x equal -1. And then from asymptote, cross at 0, 0 and above. This is Fx. Domain of F equal to range of F inverse is, domain of F is from -infinity to infinity. Range of F equal to domain of F inverse from asymptote -1 to positive y means infinity. So these are domain and range for F and F inverse. And this is your exercise. Please submit the exercises at the end of lecture.